in this table, we have been given information about a student's major and their class. And now we want to use this to calculate some probabilities of some different events happening. The first one, we want to find the probability that a randomly chosen student is not a junior. So we want to find probability of not junior. And to do this, one thing that you could do is to take all of your columns that are not juniors, so our freshmen, sophomores, and seniors, and add those together to get our number of students that are not a junior. However, depending on your table and what you have in your problem, if you're dealing with a lot of data, that might be a lot of work to take all of your columns just to figure out your probability of not one of them happening. So instead of doing it that way, we're going to work through it a slightly different way that is more beneficial if you have a large data set, using our complement rule. Because if we think about it, our probability of not junior is equal to 1 minus the probability that they are a junior. And now we have that probability of junior. Well, there's 36 juniors out of the 125. So we are going to be subtracting off 36 over 125. So we have 1 minus 0.288, which then that will give us 0.712 for our probability that they are not a junior. The next one, we want to find the probability that a randomly chosen student is a junior or an education major. So we have an or statement here, junior or education. So we want all of our students that are either junior or education or both. With this is going to use our addition rule. So we are going to want our probability of junior plus the probability that they're education minus the probability that they are both of those two things. So now in our table, if we take a look at our junior column, we can see that we have a total of 36 juniors. So probability that they're a junior is 36 out of 125. And then we need to take a look at our education row. So we have education major, and we have that there is 63 total education majors. So probability that they're an education major is 63 out of 125. But now we need to subtract those that were counted both times. So if we look at our overlap here of the junior and education, those 21 students were counted both in the 36 and 63, so we need to subtract them off. So we need to subtract 21 out of 125 because they were double counted. So now with this, all of our denominators are the same, so we can add and subtract the numerators to get our answer. So 36 plus 63 minus 21, and you should get 78 out of 125. And now we can then get our decimal equivalency of this, which gives us about 0.624. The next one, we want to find the probability that a randomly chosen student is not an education major, or they are a freshman. So now we have another or statement here. So I'm first going to look at our not education major row. And we can see that we have 62 students that say they are not an education major. So our probability of not being education is 62 out of the 125. And then I want to add on the probability that they are a freshman. Well, our freshman column has a total of 26 students. So we have 26 out of 125 for freshmen. But now, once again, we have overlap that we need to subtract off, because these 14 students that are both freshmen and not education majors have been double counted. So we need to subtract off 14 out of our 125. So now 62 plus 26 minus 14, and we get 74 out of 125, which then gives us 0.592 as our probability. Okay. Lastly, we want to calculate the probability that a randomly chosen student is a senior and not an education major. So now we have an and probability here, which means we want to find our number of students that satisfy both of those two conditions at the same time. They are both seniors and not education. So if we look at our our not education major row, and then we also take a look at our senior column, the and is just strictly looking at the intersection of these two. So we can see that our overlap is 25. So our probability of being a senior and not education is going to be 25 out of 125, which then that gives us to be 0.2 for the probability.